1.4, solving linear systems by the Gauss Jordan method. Gauss Jordan is just kind of the next logical step past echelon method. If you remember echelon method, we wanted a triangle. And so we're gonna, we were gonna do this. That's not what I want here. Okay, that is not what I want with Gauss Jordan. We want to start with something called the augmented matrix. And augmented matrix just takes out all of the symbols. So I see 3 equations or 3 rows. We're going to have a matrix with 3 rows. And in the top row, I've got a 2 for the x, 1 for the y, -1 for the z. And then you're going to draw a vertical bar, and that vertical bar represents the equal sign. And on the right side of the equal sign is a 2. That's the top row. So 2x plus y minus z equals 2. I took out all the variables, all the symbols, and that's what I get. So the middle row, you've got 1x, 3y, 2z equals 1. Make sure you're lining up your variables. You should have an x column, a y column, a z column. Every once in a while, they'll put them in a weird order. You might have to mix around the order so that they're lined up, but make sure you're lined up because you want rows and you want columns. So then the last row, x, y, z, 2. That's the first step for this process, is come up with the augmented matrix. You should recognize the row operations because it's the same thing as echelon method. It's the exact same thing, the exact same process. Whoa, how'd that happen? Exchange rows, multiply by a non-zero number, replace an equation with a multiple of itself. All right, if you replace an equation with a multiple of itself, that's where we're doing like row 2 minus 3 row 1s. That's what I'm talking about. So those are the main row operations there. Here's how you solve by Gauss Jordan. Step 1, write the augmented matrix. We just did that. That's pretty simple. That's pretty quick. Step 2 is the big one though. Use row operations to produce numbers along the main diagonal and zeros in the lower left and upper right triangles. Here's what I mean by that. What we want to see is something that looks like this. So read that again. We want numbers along the main diagonals and zeros in the lower left and upper right triangles. So basically, numbers along the diagonal and zeros everywhere else. That's what we want. So if you think about echelon method, we needed to zero out this, this, and this. For the echelon method, we tried to put zeros in those 3 spots. But Gauss Jordan takes it another step further and also wants zeros in these 3 spots. So it's going to be more work, but I kind of like it better because it takes out the variables and just looks at numbers. So think about what we might have started with. We might have started with something that looks like this augmented matrix. And remember that top row is an equation. It says 2x plus y minus z equals 2. So knowing that this is an equation, really, we can kind of go backwards and look at the top row as an equation that says 4x equals 12. That top equation says 4x equals 12. And if you look at it right, you can solve that equation in your head and you know that x equals 3. All right, everybody see how x is going to equal 3 here? So just skip a step and do that part in your head for the next one. And the next row says 2y equals 20. So if 2y equals 20, then I can see pretty quickly that y equals 10. I can do that in my head. And the bottom row, can anybody tell me what z is going to equal? Z is going to be 6, because that says 5z equals 30, so divide by 5, whatever, that's going to be 6. So if you can get to here, you're in great shape because it's an easy solve. That's kind of the dream. That's where we need to get to. Now, when it says reduce, technically what we want is we want 1s here, and that's going to be called reduced row echelon form. That's technically what we want. But if you can get to just numbers like the 4 and the 2 and the 5, we're there. That's the hard part, and that's it. Now, the way I do it, I like to make the zeros first, but the way a lot of people will do it is they'll make those ones first. And my way I like better because it avoids fractions for as long as possible. If you produced the ones first, you're going to have a lot of fractions to deal with, and it becomes a mess. So I like my method. We're going to make those zeros, and then we're going to make those ones. Example 1, use the Gauss Jordan method to solve each system. So step 1 says, give me the augmented matrix. You need to write kind of small. There's a lot going on in these problems. Augmented matrix. I think half the battle is just knowing what in the heck you're doing on these problems. So this is not Echelon method. This is Gauss Jordan method. And what Gauss Jordan method wants essentially is numbers along that diagonal and zeros here and here. So it's really a very similar process, except we don't want the triangle, we want the diagonal. All right, so there's more to it. Now we start and we work our way from left to right. So we're going to look at this 7 first, and we're going to try to knock out this 7. I would circle this 4 because we're going to use the 4. You're using the one that's on the diagonal to knock out the one that's not. So again, just like Echelon method, it has to do with an LCM. The least common multiple of 4 and 7 is 28. And so the simplest way to do it is to come up with a rule that says 28 minus 28. All right, 28 minus 28. There are other ways with larger numbers. 56 would work, but 28 minus 28 is going to be the easiest way to do that. Okay, so how I can do that is I can say 4 of the 7s minus 7 of the 4s. That's going to be 28 minus 28. So that's one way to do my rule. So before we do our rule, I would just probably copy down the top row. Top row, the one that you've circled, doesn't need to change. It's the bottom row. It's the 7. It's the one that wasn't on the diagonal. That's the one that I need to change, and I'm going to use my rule for that. So use a calculator. I mean, those of you that are really good at multiplying and adding and subtracting and stuff quickly, you may or may not need one, but most of us, until we really get comfortable with this, could really use a calculator with parentheses. So what this says is 4 times the row 2 number minus 7 times the row 1 number. That's 0. Of course it is. And so with Echelon method, I had you put a dot to hold its place, but here we're going to put a 0. I mean, it's the same thing. You're zeroing that out. You're canceling that out. So we move on, and now we need to change the 8. Now we need to change the 8. We're going to change the 7, the 8, and the 19. We changed the 8. We're going to use the same rule. The rule says 4 of the 8s minus 7 of the 5s. 4 row 2 minus 7 row 1. That's negative 3. And now we do the same thing with the 19. 4 of the 19s minus 7 of the 10s is 6. And at this point, you're going to be tempted to go back and do Echelon method. Because can you tell me what y equals right now? That bottom row says negative 3y equals 6. And so with a little bit of arithmetic, you can see that y equals negative 2 right now. Y equals negative 2. And so you're going to be tempted to say y equals negative 2 and then plug in that negative 2 to figure out what x is. But that's Echelon method. That's not Gauss Jordan method. Okay. Half the battle is just knowing what you're doing. And what we're doing here for Gauss Jordan is we've also got to zero this thing out. All right. The Echelon method is pretty much complete. We did that step, but we've got to go farther because Gauss Jordan requires us to do more. All right, so now we've got to knock out that 5, and we have to knock out that 5 using this number that's on the diagonal. Okay, wait a minute, time out. One of my row operations is I can multiply or divide by a number. It was number 2. Multiply equation by a non-zero number. And I'm going to do that just to reduce my numbers down. So I'm just going to kind of like see how I can divide by -3 here. Everything's divisible by 3, or everything's divisible by -3. So I'm going to do that, and that changes this to 0, 1, -2. And I'm going to scratch that. And I'm going to use the 1. Like I've got smaller numbers, and it's going to be easier to do LCMs here. 0, 1, -2. I need to knock out the 5. And you could knock it out with the -3. All it takes is an LCM of 15. Okay? But if I reduce that, now I can knock it out with a 1, which is going to be a little bit easier because it's a little bit smaller numbers. So you need a rule again. So I'm knocking out a 5 with a 1. I should be able to say row 1 minus 5 row 2s. Because I'm using the 1 now, not the -3. And I do that all the way across the top. I need to knock out the 4, the 5, the 10. All right, I need to change the 4, the 5, the 10. So my rule says take row 1 minus 5 times the row 2 number. And I do that across each column. So 4 minus 5 times 0 is 4. And row 1 minus 5 times row 2 is a 1. That's 0, of course. That's why I picked what I picked. And then we do the 10 with the -2. Row 1 minus 5 of the row 2's was -2. That's 10 plus 10 is 20. So that's my new top. My bottom's good. Just leave it alone. 0, 1, -2. That's good. Okay. And so essentially we're finished because we can see the answer. You can see that y equals -2. Can you also see what x is? X is going to be 5. 20 divided by 4. All right. But technically this isn't reduced. It's not reduced until you see 1s. And so I would probably go one more step and divide this one by 4. And I get 1, 0, bar 5. Oh, shoot. I'm running in my space of the other one. And 0, 1, -2. That's what's called reduced row echelon form. And that's really what we're after, because that tells me my answer. X equals 5 and y equals -2. Or write it as an ordered pair if you'd rather. Okay, that's Gauss Jordan. So number 2 is more of the same. Start with the augmented matrix. 1, -2, bar 2, 3, -6, bar 5, augmented. You always do it the same way. We want numbers along that diagonal. We want zeros elsewhere. And so the first one I'm going to knock out is this 3. We need to knock out that 3 using the 1. Okay. So we need to come up with a rule knocks out a 3 using the 1. What can we do? Row 2 minus 3 row 1. That'll be 3 minus 3. That'll be 0. Leave the top row. The top row is fine. 1, -2, bar 2. But the bottom row I'm going to knock out according to this rule. So I've got row 2 minus 3 of these. That's 3 minus 3 ones, 0. And row 2 is -6. Minus 3 of the row 1s is -2. Ooh, that's also 0. And row 2 is a 5. minus 3 of the row 1s is 2. It's a negative 1. Okay, this is a weird one because we can't get those numbers along the diagonal. There's no point in going farther. Gauss Jordan would have me try to knock this out, but you're actually not going to be able to knock it out because this zero is not going to allow you to knock out that negative 2 by this process. But we also know what this last line means. This last equation, this last line says 0 equals negative 1. That's a false statement. And when we get a false statement, we know that there can't be a solution. So that's your indicator that this is going to be no solution. Number 3, there's a lot more going on that one. Okay, if you look at my notes, you can see how much space it takes up. There's a lot going on. There's a lot going on in this problem. And so that's why I'm going to show you a shortcut, and it's going to be a huge shortcut using your calculator. Do I have time? 5 minutes or so? All right, let's see. You still have to get the augmented matrix. And this one's kind of weird because the variables are out of order. So make sure every time you put the variables in the same order. It doesn't necessarily have to be XYZ order, but that's probably what would make the most sense. So I'm going to subtract this y over. So I can put it as x minus y plus 5z equals negative 6. And I'm also going to subtract this z over. Make sure you put it in the right place. So that says 3x plus 3y minus z equals 10. It's really important to line up your variables. If you get them out of whack, you're going to get confused. The third one's fine as is. It's already in standard form. So let's just write this as our augmented matrix. 1, negative 1, 5, bar, negative 6, 3, 3, negative 1, 10, and 1, 3, 2, 5. Good? Okay, I'm going to call this matrix A. You can call it whatever you want. It doesn't really have to be matrix A. But what I want to do is I want to do a reduced row echelon form of that matrix. Okay, and so I'm going to show you 2 different ways. I'm going to show you with a website, and I'm going to show you with your TI calculator. So pay attention and follow along and keep up. I'll show you a website first. You're going to need to just go to a search engine and type in like Gauss Jordan calculator. I've got one linked to my website, but it's currently blocked. So I'm going to have to figure out how to get around that. There are several different ones you can use. You just need to find one that's easy for you. I think this one's decent. So the first thing you need to do is tell it what size the matrix is. So look at what we got. Our augmented matrix, what size is that? That's a 3 by 4. So just tell it it's a 3 by 4, so it'll give you enough spaces to enter in the numbers. Okay, now we need to enter in the numbers, and I like using the tab key. I think it's efficient to use the tab key. 5, negative 6, 3, 3, negative 1, 10, 1, 3, 2, 5. All right, got them all? Hopefully that's right. Hopefully I haven't made any mistakes. And so we're going to calculate, and it's going to think and do some stuff, and there we go. All right, so it takes you through kind of all the steps. Now, one thing I don't like about this is it does it backwards from the way that I do it. This is the way most people do it, actually. Like when I would do this, I would find zeros first, but everybody else finds ones along the diagonal first. And doing that gives you all these messy looking fractions, and it's really hard to deal with once you're looking at all these fractions. But whatever, long story short, you scroll down and there's your reduced row echelon form. So we can write, okay, that's your answer. 1, 0, 0, 1. And then it was 0, 1, 0, 2. In the third row, 0, 0, 1, negative 1. Which is awesome because that tells me exactly what the answer is. I can see from that top line shows me x equals 1. That middle line shows me y equals 2. And that third line shows me z equals negative 1. And this will work for the smaller examples that we just did before. It'd just be a different size matrix. Okay, now, don't put your stuff away because I'm not done yet. I'm also going to show you how to do it on your graphing calculator. I've got like a... I am done. Okay, well, if you want to see it, stick around. Here we go. So you need to go into the matrix menu and give it the size. So we go over to edit, and I'm going to edit this A and tell it it's a 3 by 4. So I enter in those same numbers, which were 1 and negative 1, 5, negative 6, 3, 3, negative 1, 10, 1, 3, 2, 5. So once I get out of there, I quit and go back in. This time you don't want to go to edit, you want to go to math and scroll down to choice B, RREF. Don't choose A, it's something different. You want RREF. So you hit enter, it takes you back to the home screen. Now you got to put the matrix inside there. So we go back to the matrix menu again, and you just have to grab it, hit enter, and there it is. Same thing, reduced row echelon form.